So yeah, thanks for the formal intro. So I'll introduce myself a little bit more informally. So I'm David Federer. I'm a nerd. I spend my time coding in Python and C++ and R. I really enjoy that. So what I actually wanted to do today is give you more of a technical view on how you can roll out AI and data science in an organization, how you can drive business outcome with that. So yeah, it's going to be a little bit more technical than we have seen today, but I hope you guys stick around and don't leave the room just now. Just a little bit about calls first, about Flybys. Yeah, so Flybys basically is the loyalty program that is powered by calls. It's basically a mechanism that calls use to increase the stickiness of customers, so that customers return to call stores and do their shops at calls. It's one of the most successful loyalty programs in the world, so it has a very high penetration rate in Australia. And basically what we're looking at Flybys, sorry, hay fever is killing me. What we're looking at Flybys is how we can actually leverage AI and data science to increase the stickiness of customers to our loyalty program. But also we service the wider calls community, so we do projects across the company. Sorry. Let's do some water. So what I actually wanted to talk about today is how you can make the performance of AI tools and agents and data science models transparent for the business, and how the business can hold you account, as to how data science models and AI models perform. So what I wanted to do first is, before I kick into that, I wanted to just talk about what intelligence really is. Because we're speaking about AI, and speaking about augmented intelligence. Basically, I feel the strong urge to actually discuss what intelligence really is. So let's have a chat about it. So what really characterizes intelligence is, firstly, the ability to learn and remember. So real intelligence, whether it be artificial or human, has the ability to basically pick up and learn events or data and store that and remember that when it plans actions or when it needs to take action or reason about something. So that's a very important characteristic. Now the second one there is stimulant perception. So what AI can do, what intelligence can do, is process a huge amount of data and leverage that in some sort of way later on in the line. So stimulant perception, read it as stimuli, read that as data. Process huge amount of data is a very important aspect of intelligence. Rational behavior definitely is a very important ingredient of intelligence. What rationality basically means is to optimize your own goals. So if I have a particular goal in life, collecting stamps or whatever it may be, I want to optimize that goal, and that's what rationality is. So every intelligent agent has a different, as we call it, fitness function, or a way to optimize its goals. But in that sense, it's rational. Now the other piece, and this is what humans are really good at, is to perform mundane tasks. So we can all see, we can all feel, we can all process visual information. We can speak. That is something that we are really good at. Artificial intelligence is not so good at it. We have to teach it. It's for artificial intelligence not so. Doesn't speak for itself. Reasoning is an important ingredient as well of intelligence. So basically, if you're an intelligent agent, you can reason about your actions or about things you've learned or seen in the past. So reasoning, very important one. Social behavior, definitely an important one. We're really good at that as humans. AI agents are less good at it, but increasingly getting better and better at it. But basically what it means is in engaging with other intelligent agents and reason about actions or collaborative actions we want to take or collaboration or exchanging ideas. And the last one is emergent behavior. That's a very important one. So emergent behavior, really what it means is do unexpected things in the eye of the beholder. So I might be an intelligent agent, and I might do I might take actions that are not so apparent to you guys. And the reason I do that is to increase my, to basically chase my goals in life. So yeah, that's what those are the characteristics of intelligence. Now, basically, what we do, and I'm not going to go there, but I just want to I can't stop myself from mentioning it. When we talk about artificial intelligence, we're actually a little bit discriminatory, right? Because what we're saying is we're labeling something as artificial, whereas who says that we are so intelligent and something else is artificially intelligent? So basically, really, what I do is I talk about human intelligence, so amino acid implemented intelligence. And artificial intelligence would then be silicon-based intelligence. So basically, transistors and robots that are based on silicon-based technologies. But it can both be equally intelligent. Who says that me as an amino acid-based intelligence, form of intelligence, that I'm more intelligent than a silicon-based form of intelligence? So that's just in a nutshell what intelligence is about. Now you have different notions of intelligence, and I'll very shortly I'll come to the point where I'll start telling you why, which notion is applicable to a business application and which notion isn't. But you have different notions of intelligence. You have the strong notion of intelligence, so strong AI, and that is actually it relates to developing capabilities that are human or beyond human intelligence. So basically, an intelligent agent that is rational, that has its free will, that is autonomous, that can do things by itself, that is not subservient or dependent on anything else. So that's a strong view of AI. Now, this type of AI we're not going to encounter anytime soon in our company. So we don't have all these gloom and doom stories about AI taking over the world and rogue AI and AI cutting away our jobs, and that is, strong AI will do that to us, but strong AI is not anywhere near being developed. What we really use in our businesses is weak AI. And weak AI is also referred to sometimes as augmented AI. And what augmented AI really is machine learning that helps us perform particular tasks that are very specific. Okay, so if you have a particular business problem or problem that we want to solve in our organization or our business, then we can train a model or a weak AI model, a machine learning model, to actually address that very well. And that particular problem can be solved by AI very, very, very well and much better than we could solve it as humans. So sometimes it may seem that weak AI looks very intelligent, but in the end of the day, it's just a trained machine learning model that is subservient to what we wanted to do. Cool. So now, how do you measure the intelligence of humans? Well, I'm not going to drill into this too much, but you have all these IQ tests that you can apply to human intelligence. And basically what it does is it serves as proxies for human intelligence. So if you turn out well in terms of an IQ test, then as a human you're pretty intelligent and you know how to crack particular problems, or you know how to, you're very good at pattern recognition or whatever those IQ tests measure. Now for weak AI, you need different measures to measure intelligence. You're not after those IQ tests that are applied to humans. You're after a different type of measuring IQ. The first notion here is that strong AI, as I said, is not really required for most of the business problems that we face on a daily basis. So if you want to build a propensity model, to predict if a customer is going to lapse or churn, we don't really need strong AI for that. So strong AI will be an overkill for almost every business problem. You simply don't need the cognitive skills that humans have to crack those problems. More often than not, number crunching is enough. So weak AI really is sufficient for most business problems. And now the problem, and this is where I really get to the gist of what I want to present, is, and this is how we're addressing this at calls, is many times you get asked by business stakeholders like, okay, but you have built this awesome model and we believe that you've done a good job, but show it to us, prove that this model is a really cool model and it really does what it is supposed to do. Because we don't believe you And if we don't believe, you're not going to sign off on this. So what I've been really thinking about is really how I can communicate to the business how well a model does. So we as technical persons, we need to make, we need to be able to actually communicate to the business like, hey, this is really awesome. This neural network really addresses a particular, lip sync model, or increases stickiness of the customer to our loyalty program, or whatever business problem you want to solve. And then basically the other component of it is that you enable the business to basically assess what you are doing. So I'm having conversations with business stakeholders in terms of, hey Dave, so how's the model tracking? Yeah, so it's the accuracy is up from 95 to 98. Oh, that's really awesome. So my business stakeholders understand what I mean by it, and I'll drill down into that a little bit more. Now this is as technical as it gets. So. Basically what I wanted to show you is different components. So we already spoke about all the characteristics of AI. So rationality, the ability to learn, ability to remember. So basically if you want to test a model or an AI agent on its ability to learn, then there's a couple of measures you want to look at, and you may want to communicate to your business stakeholders. And your business stakeholders don't have to understand the math behind it. All the business stakeholders need to do is treat it as a metric, so that they can assess, in the same way as they would use any other metric, for example, sales or revenue. So what I'm showing here is a model that predicts which customers are going to open a mail. So what we do at Calls, we send out a lot of mails to our loyalty program members, Flybus members, and what we want to be able to predict is which customers open, particular mailings. So we have a couple of AI models in place that basically do that for us. And what I wanted to discuss is a few of those metrics very briefly, so that you have some sort of a sense of how I communicate to my business stakeholders. So accuracy basically is the ability of the model to nail, in this case, which customers are not going to open, or which customers are going to open an email. So what you're seeing is that this model has a 90% accuracy, where it predicts correctly the customers that won't open an email, and also the customers that will open an email. So that accuracy normally lies between 80 and 95. So when I come to a stakeholder and I tell the stakeholder, okay, my model is doing 75% accuracy, then that stakeholder will say, well, actually, you need to do a little bit more work on this. And so I can be held to account to improve this model. But at the same time, it creates trust with the stakeholder. The stakeholder knows that I'm completely transparent with them, and that I'm doing everything to get the performance up, rather than just selling a black box. The other one that's really interesting there is precision. So precision, basically what it does is, and it should always lie somewhere between 60 and 80%. Precision, what it really does is, out of all the instances that I predict a customer to open their email, what is the proportion of true openings? It's a very important measure. Another one a little bit related to it is recall. So recall basically means, out of all the true openings, which one did I correctly predict? There's another measure as well, which I'm not going to go too deep into right now, but it's called AUC, area under the curve. And basically what it means is the ability of the model to rank positive cases over negative cases. And RMSE, you may have heard of it, is the root mean square error. And basically it gives you the chance that your model is going to be off. So the higher that figure is, the worse your model does. Cool, so that basically relates to your ability of your model to learn. So that's how you would measure the capability of your model to learn and remember. Okay, before I go on introducing all the other characteristics and how we communicate it to the business at Calls, I just want to introduce a use case that we have where, so I don't know, does any one of you order online their shopping or their groceries? Cool, yeah, so basically the complexity that you have around this problem is if you have a couple of people who order their groceries online, then you need to kind of work out what the best route is for the driver to drop off all those deliveries. So it's called a traveling sales problem in AI speak, and it's a very common problem. So it's basically used for all routing problems and all route planning problems. And of course, we have those type of problems as well. We use the traveling sales related algorithms to solve that. So basically, the objective here is to minimize the overall distance traveled. Now, just keeping this use case in mind, the other characteristic that I mentioned was the processing perceptions and stimuli. So read it as data, processing vast amounts of data. So basically what you want to measure as well is a reaction time. So how long does it take for an agent to come back to you with an answer? It's a very interesting concept as well. You don't want to run a model and wait for hours for the model to come back to you. You want the model to be pretty fast. So what we do is we talk to our stakeholders and we basically emphasize the importance of reaction time. Scalability is another one. So scalability is if you add a let me just back up one slide. If I were to add extra nodes or extra dots in that, if I were to add extra waypoints, would the complexity of my model increase linearly or exponentially? If it would increase exponentially, it would not be scalable. So that's something we also teach our stakeholders. Like, focus on that as well. Don't pay attention to how scalable models are. If I cannot produce a scalable model for you, then probably I need to rethink the design of my model. So you don't want this curve. And parsimony. Parsimony is an interesting concept as well. It's basically limiting your input stimuli, your input data, to the absolute required amount, the set of variables that are most telling of your problem, and that most, in the best way, explain the phenomenon. Cool. So rationality. So I already talked about this use case, right? Where we have this traveling sales problem, and basically what I coded up is a community of generic algorithms, a couple of generic algorithms that talk to each other and cooperate to get the best result. So what you're seeing here is that what you're basically looking at here is a fitness function, or how rational an intelligent agent is. And what the goal here really is the minimization of the overall amount traveled by a truck driver. And one of the other characteristics that is really interesting and really important is the speed at which the goals are achieved. So if you run your traveling sales algorithm and it takes forever to converge on a particular solution, then it's not any good. So what I explained to the stakeholders as well is that is an important factor as well that you need to look at when you design and build AI agents. Another one here is reasoning. So reasoning is actually a very important one, and this example is a little bit contrived in the sense that most machine learning problems and models are not really able to reflect on itself, but in a sense they can if you kind of bake it in. What you basically want and if you really implement it well, what you basically want your AI algorithm to be able to do is reflect on its own performance. You want it to be able to reflect on its own performance and get smarter. So you need to sort of bake in a mechanism that has the ability to do that. And what we've done, of course, we have actually built this kind of stuff. So we have mechanisms in place that our AI agents use to track their own performance, and so we can intervene and they can improve themselves as well. And then basically what we look at is accuracy, recall, precision, all these metrics that I previously mentioned. And social behavior, that's another interesting one. So social behavior doesn't only happen between humans. It can also happen between AI agents. So you can have two generic algorithms talking to each other. Actually, I've implemented that. I just showed you that traveling sales graph. That is actually an implementation of two, various generic algorithms talking to each other and improve each other and collaborate to actually get the maximum result out. So that's an interesting one, and it's also a very interesting one for chatbots. So when you design chatbots, what you want to focus on is how that social interaction happens between a chatbot as an intelligent agent on one side and a human on the other side. So there's various ways you can measure that. For example, you can use a Turing Test, which establishes, at which accuracy an examiner will be able to pinpoint the agent as a human or as a computer. That's the one that's used, but it has a lot of flaws. But also, you could measure the proportional intuitive responses. So I don't know if it's legible at all in the room, but I've pasted in a conversation that I had with cleverbot.com. And actually, I was quite amazed how that social interaction occurred. And at first glance, I thought that many of the responses weren't really intuitive. But actually, when I thought about it, I found that many of the responses that I thought were not intuitive were actually made a lot of sense. For example, there's one there, the first one. So I'm asking the Cleverbot, how are you going? And he replies, enough. Well, at first glance, I thought it wouldn't be a very intuitive response, but actually, when I thought about it, you could interpret it as, hey, don't mess with me. I don't want to deal with you at all. Leave me alone. Enough. So it is. Those are things that you can measure as well. And you can communicate to your business stakeholders, and you can ask your business stakeholders, what is your intent behind this Cleverbot? Should it be a collaborative bot, or should it be a what they call disurgic bot? So should it not be collaborative? Should it be sabotaging you? So you can think of all these kind of scenarios where you can try to flesh out what you want your agents to do. And this is my last slide, and this is just kind of clarifying a little bit more on disurgy and synergy. So I was talking about these two genetical algorithms that collaborate, but you can also make them sabotage each other. So I can actually code these algorithms up in a way that they take each other down. And that's what I've tried to do here. So what you see on the left side, where it says disurgy, is that when you program these algorithms in such a way that they sabotage each other, you see that the overall performance, the resultant of their efforts, basically is lower than the individual level of effort. For synergy, you would see that the collaborative effort is more than the sum of the parts. So it's really cool. You can do all this cool stuff with your AI agents that you build. But also, what you have to make sure, and I think this is the gist of my presentation, is that you make it transparent to business stakeholders. So don't only talk about it in terms of black boxes, but try to get them onto the journey and try to make them come your way as a technician to understand how you measure these kind of things and how you measure the performance of an AI agent. So yeah, those are my 3 takeaways as well at the same time. So don't think too big. Weak AI solutions are definitely fit for most problems that we have in the business. And make the performance of your AI agents measurable and convey that to the business. And make the business understand what those terms mean. What does accuracy mean? What does recall mean? It's not that hard to understand. I mean, everybody means what revenue means or the sales mean. So why would a business table not be able to understand what accuracy means? So I think I'm a little bit ahead of time, but I designed this for a group of managers that calls, so it needs to take 20 minutes, not more. So yeah, Q&A. Do you guys have any questions for me? Or
any questions? You in the traveling salesman use genetic algorithms, which is a traditional approach for the problem. Have you tried any other AI technique?
Yeah, we do. So we use the whole variety, ranging from neural networks to GAs. We also combine those into communities. So you can blend them. You can build various instances of algorithms and let them speak to each other and merge their performance into really well-performing model. So you can do all that stuff. I've looked at various, we use various techniques. It's 5 o'clock.
It's 5 o'clock. It's hard for
It's-
brains to work. I thought, very cool that you're having sort of chatbots or bots trying to take each other
Yeah.
down. What's the benefit to Coles of that? Or is that just a mystical experiment?
Oh yeah, so it's more of an experimental thing, but basically you can think of maybe in a realm of banking, you can think of fraud detection. So you want an AI agent to be very dissurgic, to be very cynical to the agent it's interacting with. You don't want it to believe it.
Okay.
So yeah, that's how you could use it. Of course, we're not really applying it, but I just wanted to squeeze it in as an example of how you can use AI as well.
Yeah.
You can also make AI cynical. It doesn't always have to serve you. It can also be critical to you. Yeah.
I'm just interested. We're reasonably immature in this space, but when are you finished with your model?
Yeah.
So, how much? We're constantly training, and I suppose it comes to a point of your metrics because we're not in the lucky space. We're relying on data coming in to constantly improve our models. But
Yeah.
I'm thinking I can't do that forever and a day.
Yeah. So.
It's like a painting, I guess.
Yeah, no, that's a good question. I mean, that is actually why this came into being, because what we want stakeholders to do is to be satisfied with a particular result. So we don't have, a predictive model or a machine learning model or an AI agent doesn't have to, perform at 99% accuracy. And maybe it's good enough if it performs at 85%. So what we're doing, we're taking the business stakeholders on board to actually understand those concepts. So they can say, well, actually, 85%, that's good enough. I'll sign off on that. Yeah.
I suppose we've given business a fair bit of access to the data, which probably may have been a mistake as well. So we struggle to get a lot of test data out of them.
Okay. Yeah.
They're really happy to train, not so happy to test.
Yeah, that's a common problem.
Well, and that's also, and just another point, I was thinking about it from one of the other speakers as well.
Yeah.
I work for the South Australian government, so we have done a lot of work of opening up data sets and progressively opening up more live data sets for business.
Yeah.
Business is generating a huge amount of data. Well, where's that line of being able to share that, privacy concerns aside? Does a company like Coles feel that there is some sort of public good in sharing some of that data, or is it not really a conversation?
So many companies think that is the case. I think that's a very good thing. Sharing data, and sharing platforms. Coles specifically is not really keen on doing that for obvious reasons. Think of supermarket wars. But yeah, it is, as a principle, it's a good thing. Yeah.
Because as trying to open up data, just so there's that sort of the sum greater than the sum of the parts, you can sort of cross-reference huge range of data that you may not ever think of.
Yeah, agreed.
There's such a big benefit, and also business is benefiting from a lot of the public data that's made available.
Yeah.
So some sort of give and take in that process.
Yeah, correct.
Yes.
Yes.
Just in terms of chatbots, in terms of accuracy, so at what point do you determine, say, either your intent set may be too small, therefore the accuracy is bad,
Mm-hmm.
versus whatever the person's putting into the bot is just gibberish, rubbish?
Yeah. So you would, the assumption is that the use of those metrics would basically bring that to the surface, right? So if your metrics are trending down, so if you get really bad accuracy figures and really bad recall, then basically that will be a reflection of how well the agent will be doing. So as a business stakeholder, you'll be able to make a call and say, well, I'm looking at those figures, I'm looking at those metrics, and I think it's doing a really bad job. Rather than later down the line finding out that your agents are not doing well. Is that an answer to your question, or is there a?
No, maybe it's not the right question.
Maybe I haven't answered it correctly.
What So
Yeah.
we have essentially the answers to what we think the person's going to be asking,
Yeah.
and then we have the utterances which we train against to link between the two. So where is a good place to try and figure out where that intent set is lacking, or the utterance training is failing?
Yeah. Okay, got it. So basically, that is so. What? Okay, yeah, there's a very concrete answer to the question. Basically, what I've spoken about is sort of your benchmark, right? Where the performance of your performance metrics need to range between 60 and 80%. So really, if you're doing worse than that, you know that you've got a problem. And if you can't improve with all the effort of the world, you can't get the performance of your AI agent up, then you know that you're in jail. That you have to look at it. You either have to enrich your data set, or that you have to, maybe you've made a mistake, or maybe your labeling is not correct. So you have to review the way your data is labeled, or maybe you have a data quality issue. Normally, if you can't get, with all the effort of the world, if you can't get the performance of your AI agent up, you know that you have a data problem. If that makes sense. Yeah. Any more?
Any more? No? Well, thank you very much.